right, so this symbol theta often will be used to designate a angle measure. And with respect to whichever acute angle, when you take a trig ratio, you're going to take that trig ratio with respect to a specific angle, which we'll call theta. And wherever you choose your angle, the legs will be named or labeled based on their relationship to that chosen angle. So this leg is opposite the angle. This leg is adjacent. So opposite and adjacent refer to the legs of the right triangle. What's the other side of the right triangle called? Hypotenuse. And that's not going to change. That'll be the same regardless of which angle that you choose. So in terms of the red angle here, here's the opposite side, the opposite leg, the adjacent leg, the hypotenuse. If I took this same figure but I chose this angle here, and so the symbol that's used here is theta prime, just gives a secondary angle with the same kind of labeling. But these are two different angles. In terms of the blue angle, this leg is opposite and this leg is adjacent. Okay, so the adjacent leg is part of the angle, the opposite leg is not. Okay, when you refer to your trig ratios, there's three that we're going to talk about this year. You'll learn some other ones next year. But the three that we're going to talk about are sine, cosine, and tangent. Okay, these are the three common right triangle trig ratios. And like I say, these are simply ratios between different parts of a right triangle. Okay, the sine of an angle is the ratio of the side opposite the angle to the hypotenuse. Okay, the cosine of an angle is the ratio of the side adjacent to the given angle and the hypotenuse. And finally, the tangent of an angle is the ratio between the opposite side and the adjacent side. Okay, and so there's an acronym that's used to remember these. Those of you who've been exposed to it have probably seen it, but that acronym is SOH CAH TOA. And it just means exactly what it shows here. The sine is equal to opposite over hypotenuse. The cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So those are your ratios. This is something that, once again, you do need to be very familiar with. Okay, and so if I gave you a triangle, and you'll often be given triangle ABC, again, C is oftentimes the right angle. Okay, and then the sides opposite these specific angles are often referred to with respect to the lowercase letter that coincides with that angle. So if I ask you, just in this right triangle ABC, with acute angles A and B and right angle C, and then sides lowercase a, b, and c, you can write your trig ratios based just on this. So if I ask you to write the sine of A, so sine, you're just going to take the first three letters of each of these. So sine is designated as S-I-N. Okay, please, when you refer to it, call it sine. It's not sin A. Okay? It's sine. Okay, and the sine of A shows the ratio of sine is opposite over hypotenuse. So what side, what leg is opposite angle A? A. And what's the hypotenuse? C. Okay, what if I say the sine of B? The sine of angle B is the opposite B over the hypotenuse C. Okay, what if I do cosine? What's the cosine of A? The cosine of A is B over C, adjacent over hypotenuse. What's the cosine of A? Oh, I'm sorry, the cosine of B. Okay, so the cosine of B is adjacent, A, over hypotenuse, C. And then finally, if we look at the tangent ratios, TAN, the first three letters, the tangent of A is opposite over adjacent, and the tangent of B is opposite, in this case B, over adjacent A. And so anytime you're setting up these ratios, okay, this is what it's referring to. You're usually only going to solve, as far as in the right triangle problems, you'll solve ratios for acute angles, because those are the angles that you can see here in the right angle, or in the right triangle. It is possible to find trig ratios for angles that extend beyond 90 degrees. And for those ones, we're just going to use our calculators to solve them. Okay, so what I want to do first here is I want to go through and show how you would use your calculators to solve these, and then I'll go through a few problems that you would need to know how to do by hand.